Welcome to this month's Pacific Northwest Drought Early Warning System Drought and Climate Outlook webinar. My name is Britt Parker and I'm with NOAA's National Integrated Drought Information System. This bi-monthly webinar series is hosted by NOAA's National Weather Service and the National Integrated Drought Information System, as well as the USDA Northwest Climate Hub and the Oregon Climate Change Research Institute. It is designed to provide the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, observed impacts, and other relevant updates from across the region. The recording of this webinar and other supporting materials will be posted on drought.gov after the webinar ends. Next slide, please. Today's speakers are Larry O'Neill with the Oregon Climate Service at Oregon State University, and he will present the climate recap and current conditions. We then have the seasonal conditions and climate outlook from Aaron Peters with the National Weather Service Western Region. And finally, we have a 2026 snow drought, water availability, and multi-year normal perspective from Matt Warburton with USDA National Resources Conservation Service Snow Survey, Oregon. Next slide, please. There will be a Q&A at the end of today's presentation, so please use the Q&A box to submit your questions, and we'll get through as many of those as we can. OCRI is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by the Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist of Oregon. And I'll put all these websites in the chat box at the end of the intro presentation so you can find these websites. Next slide, please. The USDA, next slide. Let's see. NIDIS was established in 2006 by public law with a mandate to provide the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains a national drought early warning system where networks of partners provide information and action that can help communities cope with drought. You can stay updated on conditions in your state and local area with the U.S. Drought Portal. Next slide. To facilitate the early warning system, more precipitation observations are needed. We encourage you to join CocoRoss, the Community Collaborative Rain, Hail, and Snow Network. CocoRoss is a unique, nonprofit community-based network of volunteers who work together to measure and map rain, hail, and snow and to report conditions. To become a volunteer or to learn more, visit CocoRoss or contact your state coordinator. Next slide, please. Understanding how drought impacts you is important for drought assessment at the state, regional, and national levels. The National Drought Mitigation Center Condition Monitoring Observer Reports, or CMOR system, is a great way to submit the impacts you're experiencing from too much or too little water. This information becomes accessible to those who assess drought in your state for drought monitoring purposes and is also used for the Pacific Northwest Water Year Impacts Report. Next slide, please. If you want to receive a recording of today's webinar and other pertinent information for the Pacific Northwest DEWs, please follow the link in the chat to sign up for our emails. Next slide. Thank you to all of our speakers who will be speaking today. Please, let's turn it over to Larry O'Neill to give us the current condition summary and recap.
Thank you, Britt. Good morning, everyone. My name is Larry O'Neill, and I'm the State Climatologist of Oregon, and I'll be giving our condition summary and recap for the Pacific Northwest. Some of the key points I want to make today is that this winter, fall and winter has been really marked by a lot of extremes. So we had really extremely wet conditions, wet and warm conditions earlier in the winter, transitioning to dry and warm conditions in January, and now we're transitioning back into a wetter than normal pattern. And one of the big things that stands out to me, at least, is that this is the warmest such period on record across the Pacific Northwest, and it really inhibited our snowpack growth despite having near or above normal precipitation. And that big dry spell we had in January also inhibited snowpack, even though we had a little bit, we still have warm conditions, but no precipitation. And at this point in the water year, in the winter season, we don't expect that the snowpack will recover to its near normal values, even though there is some within the Pacific Northwest that predicted that it would occur. It has not so far. Next slide, please. So right now we've got a great storm going on. It's raining really hard outside throughout Oregon. And this is just looking at Willamette Pass, which is in the central Oregon Cascades at 5,000 feet. And this is one of the worst snowpacks that we've had in our recorded history. And we were hoping this storm would come in a little cooler, but right now it's raining hard and it's about 40 degrees up there. And so we're really concerned that this rain is going to melt what little snow is up there. Next slide, please. So the big story, big takeaways, we've just had a record warm start to the water year. So going between November and January, the Pacific Northwest, as well as many states across the West and Texas, have had their warmest such period on record. And it's really been eye-popping how much warmer it's been than normal. So during this 3-month period, Washington was over 4 degrees Fahrenheit warmer than normal, and Idaho was over 6 degrees warmer than normal. So it was really consequential for our snowpack growth. And despite having really wet periods in November and December. Next slide, please. And November and December is also quite wet across the Pacific Northwest, particularly in Washington and Idaho. So they had a great start to the water year. So much so that there was some flooding in Western Washington and parts of Oregon. Overall, Washington has its 16th wettest start, November, December, and Idaho is similarly well above normal as well. And Oregon actually is just about average, despite during that period as well. Even though we were kind of surrounded by states that got more water than normal, we didn't really receive as much. Next slide, please. And the next thing that happened was during January, we get what's sometimes referred to as a midwinter dry spell. And this is just a map of the sea level pressure anomalies. And so red is high pressure anomalies and blue is low pressure anomalies. And we had this big high pressure that was kind of parked over the Pacific Northwest for most of the month and even going into early February as well. And this caused a lot of inversions and air quality issues in the lower valleys, but it also diverted storms away to the north and south. And so we got very little precipitation. And these sort of dry spells are typical in the Pacific Northwest, but this one was especially intense and long lasting. And it was also associated with the polar vortex that was back east. So there's the big area of low pressure that's over eastern Canada and the US East. And that polar vortex kind of gummed up the works, if you will, for our jet stream and weather patterns. And so storms weren't able to come through the Pacific Northwest like they usually do. Next slide, please. And January was also, because of this big dry spell, these big ridges and inversions, January is also incredibly warm over most of the Pacific Northwest. And this just shows a departure from average temperature during the month of January. And what you can see is that most high elevation sites, so a lot of the mountain and foothill areas all across the region were much warmer than normal. The only exceptions to this warmer than normal pattern were down in the low-lying valleys in western Oregon and parts of western Washington, and then the upper Columbia or lower Columbia Plateau. And you get these cold air pools that kind of form in these valley regions, and then a big inversion or an increase in temperature with height. And so our mountain areas were really warm. And so this contributed to some snow melts during the month. And this is really significant because this part of January is usually when we have the biggest contributions to our snowpack here. Next slide, please. And January was not only warm, but it was dry. And this is just the percentage of average precipitation that we've seen since January 1st until yesterday. And all across the Pacific Northwest was much drier than normal, at least 70% of average precipitation. And in many places to the east of the Cascades, in both Oregon and Washington, there were big regions that only had 50% of normal precipitation. And so these precipitation deficits are really impactful because January is climatologically one of the wettest months of the year. So having big precipitation deficits now is not a good sign for drought conditions coming spring and summer. Next slide, please. And just to show the ranking for precipitation in January, Idaho is the 14th driest, Oregon was the 5th driest, and Washington was the 22nd driest. And much of the country as well was also dry. Next slide, please. And I just want to point out Oregon too, because Oregon seems to be a little bit worse off as far as precipitation deficits and snowpack. And during January, Oregon experienced its 5th warmest and 5th driest period on record. And it was pretty much widespread across the state in all the counties. And the really eye-popping number here is our temperature anomaly was over 7 degrees Fahrenheit warmer than normal, warmer than the 20th century average. And so this was really kind of impactful for us. Next slide, please. And so most of the rest of my talk, I want to focus on the snowpack because that's what we're really concerned about right now. So February is kind of when we're still building a snowpack, and now we're starting to really assess what this will mean for our spring and summer conditions. And across the Pacific Northwest, the snowpack is terrible, for most of it, particularly in southern Washington and most of Oregon. In Oregon, we have somewhere between 32 and 46% of average for what we should have at this point of year. And conditions are a little better in Idaho, but not much. So especially eastern Idaho is doing okay in the upper Snake and Salmon River basins. But northern Idaho is actually experiencing some big snow deficits on the order of, with having only about 55 to 62% of average. And then another place to point out is up in the Puget Sound Basin in northwest Washington, on the western slopes of the Cascades. The snowpack there is only 54% of normal for this point in the year. And so we've got these really big snowpack deficits at this point in time. Next slide, please. And just look at individual stations. So that map I showed before looks at all the stations within a basin. And if we look at some individual stations, by state, I've just counted up how many stations are at their lowest or second lowest snowpack on record, with stations with at least 40 years of observation. In Idaho, there's 20 such stations. Oregon, there's 22. And Washington, there's 7. So there's quite a bit of variability within individual basins, but there's a pretty strong picture here that this is a historically low snow year. Next slide, please. And so I'm going to go a little bit into more detail in exactly how historic this is, and I'm going to go by state because each state is a little bit different in how things have evolved and where things stand right now. If we take all the SNOTEL stations in Oregon and average them together, our Oregon statewide snowpack is only 37% of normal as of yesterday. And it is only about a fourth or 26% of the normal annual maximum amount. And that annual maximum occurs on average about 1 month from now, near the last week of March here. And right now we are just above the historic low. So for much of February, we were it was the lowest snowpack by quite a wide margin. But now the recent storm, a few recent storm systems have come in a little bit colder, has bumped it up a little bit. So now it's not as historic as it was. Next slide, please. And I just these are a couple analog or couple years for Oregon that have had similarly bad snowpack conditions. And so I want to point out 1981, 2005, 2015, and 2018. And right now we're at we're below everything except 2015 right now. And the other thing to see is that if we look forward, so that black line where it ends right now at February 20th, if we look forward over the next month, during these other years that we had really low snowpack conditions, we had some recovery, but not very much. So right now, it's not really likely that we're going to, based on historical conditions, that we're going to get anywhere close to average. Next slide, please. And this is just pointing out I just blew up the numbers here so you can better tell the years of which these low snowpack years occurred. And so right now for 2026, we're a little bit above where we're at in 2015, but we have less snow than we did in 1981, 2018, and 2005, and way below where we should be, the median in that green line there. Next slide, please. And the NRCS has this really cool tool for trying to project how much snow we could maybe expect in the coming month or two based on historical occurrences. And so the dashed curves show 3 different scenarios in which we either get average amount of snow, which is the green line, the 90th percentile amount of snow, which is the blue line, so that'd be a really snowy winter, and then the red is the 10th percentile, so that'd be a really dry winter. And what this shows is that we can expect that, if we look at the green line and what to expect, we're still going to be well below normal, so we'll be in that red shading there, which is below the 70th percentile or 30th percentile in snowpack. So at this point in time, and then by April 1st, we want to get somewhere up into the green shading area. And at this point in time, there's just it's just not likely it's going to happen. So, and it is still possible that by April 1st, we could still end up with the worst snowpack in our recorded history. Next slide, please. Now I want to go to Washington here. And so Washington isn't doing quite as bad as Oregon, but it's still doing quite poorly. So as of yesterday, the statewide average SWE is 53% of normal and only 40% of its normal annual maximum. Next slide, please. And there are a couple other years here where you can see, other low snow years in the historical record. And right now, Washington is just above the 2 previous low snow years of 2005 and 2015. But it's worse than it was in 2001 and 2024. And so 2024 is quite fresh in our mind because it had a really big impact on the water supply in Washington. Next slide, please. And this just shows a blow up of the amounts in the different years. So you can see where we're at right now. So it's the 3rd worst as of this date for 2026. Next slide, please. And if we do a similar projection exercise for Washington as we did with Oregon, we'll see that, based on, the historical occurrences over the next couple months, we do not expect to get anywhere close to the average snowpack. We'd really need an unprecedented amount of snowfall over the next couple months to get back to the normal level here. So that seems really unlikely based on historical conditions. Good news is that it doesn't appear likely that Washington will end with its lowest snowpack on record, but it's still possible. Next slide, please. And finally, we'll go to Idaho. So Idaho is really bumping along its record low, and it's been doing so over the last couple of weeks. Next slide, please. And you look at some of the previous low snow years in Idaho. This is one of the worst, and it's just ahead of 2001 and just behind 2010. Next slide. And this just shows the actual rankings or the amounts here. And so there are other previous low snow years, for instance, 2010, 1994, 1987, et cetera, going up. And so we're really not doing well in Idaho, at least statewide average at this point. And next slide. And this projection actually shows a little bit better than Oregon and Washington did, but not by much. It shows that, we'll probably, if we get the normal amount of snow over the next month or two, we might get a little bit closer to normal, but still well below normal. And even the really high likelihood or the low likelihood occurrence of getting an essentially snowy winter won't get us very close as well. So snowpack recovery to near normal levels is also unlikely in Idaho here. Next slide. And finally, I want to end with the U.S. drought monitor depiction. So right now, this is the latest drought monitor depiction over the Pacific Northwest. So about 32% of the Pacific Northwest is in some form of drought, between moderate, D1, and severe drought, D2. The areas with the most intense drought are in kind of northeast Oregon and the panhandle of Idaho and parts of southeast Washington as well. And these are not only are kind of conditions during this water year contributing to it, but these areas have also been involved in a multi-year drought here. So we've had some precipitation deficits that really built up over the last couple of years. And so we're seeing quite a bit of impacts from that. And so that's why these regions here are pointed out a little bit more. And also I want to point out southern Idaho as well. So we've had some big precipitation deficits there, dry January, and then dry parts of last year, including that really dry spring that we had. And finally, just point out that southwest Oregon, within Douglas and Lane counties, we've actually had some pretty big precipitation deficits that have accrued there as well. And we see these in stream flows. And we're becoming increasingly concerned that these basins with a really low snowpack will have some water supply and stream flow issues going into the spring and summer. Next slide. So we've actually, because of that really wet November, December, we've actually had a lot of improvement in US Drought Monitor over much of the Pacific Northwest. And so this just shows the change in the classification in the US Drought Monitor since the start of the water year, which was October 1st, 2025. And I want to point out Western Washington and the North Washington Cascades have actually improved by 2 or 3 categories in the drought monitor, and that's owing to that really big a series of atmospheric river events we had in November, December. And we've also had some improvements in the panhandle all across Washington, Western Oregon, and then parts of Idaho as well. And so that's all I'll say there. Next slide, please. And so most of those improvements in the drought monitor came before January 1st, before we had that long dry spell. So since the start of the year, we've started to see some intensification or reintroduction of drought in a lot of the Pacific Northwest. And this is part due to the precipitation deficits and then the condition of the snowpack. And so that condition of the snowpack, unless it improves miraculously in the next few weeks, will probably become more and more depicted onto the US Drought Monitor categorization. Next slide. And lastly, part of the droughts, as I alluded to earlier, in the northern part of our region, so in eastern Washington, northeast Oregon, and in the large parts of Idaho, were due to long multi-year precipitation deficits. And this just shows our standard drought index, the standardized precipitation evapotranspiration index, over the last 36 months. And the red colors here mean very dry conditions. And so the intensity of the red color will increase with the increasingly dry conditions. And when they get to the most red, we've had a lot of both precipitation deficits and excessive evaporation in these areas here. And so this is what is partially being depicted in those regions with severe droughts in the Pacific Northwest. And last slide. So this is just my summary, and basically, just in a word, we just have a really poor snowpack, and we're really worried about it for what it means for spring and summer water supplies. There are various basins that I didn't have time to talk about that we expect bigger impacts from. But the take-home message is we do not expect a recovery of the snowpack to normal levels during the remainder of the season, despite what maybe some people are predicting in the Pacific Northwest. So thank you very much.
Great, thank you so much, Larry. Remember, put your questions in the Q&A box, and with that, we'll move to our next speaker, and that is Aaron Peters, who will be talking about the seasonal condition and the climate outlook. Thanks, Aaron.
All right, thanks, Britt. Hey, everybody, I'm Aaron Peters. I am the Western Region, National Weather Service Western Region Hydrology Program Manager. And we're just going to go through a few slides at some climate conditions in the past. Some of them might overlap a little bit with what Larry mentioned, but we'll kind of look at different time scales and a few different graphics and then go into the climate outlook. So you can go to the next slide. All right, so this is most of these next few graphics I took from the Northwest River Forecast Center, who they do a great job of kind of breaking down the precip and temperature stuff by basin. And so what we're looking at here, the graphic on the left is basically water year precipitation since October 1st of last year. And it's interesting because it does look like, just looking at the entire water year so far, that the sort of northern tier of, including Washington, northern Idaho, western Montana, looks really good. And then the Oregon, southern Oregon, Idaho basins are where we see those deficits. But really, it's sort of as Larry kind of alluded to multiple times, it's a feast or famine type of deal. So those higher percentiles in Washington and northwest Montana are really skewed by that intense atmospheric river, or multiple atmospheric rivers really, that we got in December in those areas. So all that flooding, and you can see that in the graphic on the right, that's December precipitation for those basins, and just really well above normal, and that's really kind of skewing the seasonal precipitation numbers. So we'll kind of dive in a little bit more on the next slide. Again, this might be a little bit of a repeat with what Larry mentioned, but just kind of recapping or like reiterating that January was just exceptionally dry, and as he mentioned, that it is a month that you all in those areas really rely on precipitation. So really, almost without exception, most of those basins are below 50% in January precipitation. Only a few there in sort of Idaho are higher, and then up in Canada. And then looking at February so far, so this is through the 21st, so through Saturday, not looking a whole lot better really, especially up there in those basins in western Washington. So those numbers again have really, including all this dryness, still look okay, but it's mostly just because of the December precipitation that we received with those ARs. Next slide. And again with the temperatures, so just well above normal, really, since the beginning of the year. January 2026 on the left there, lots of basins 3 to 6 degrees above normal, and almost without exception, they're above normal, and February so far as well. So, and there's even a few basins there in southern Idaho that are 6 degrees or more above normal for the month of February, which is pretty remarkable. All right, next slide. Okay, we'll get into some climate outlooks now. This is the shorter term outlook, of course, 8 to 14 day, came out yesterday. We'll another couple hours or so, we'll have another one. But looking at really the first week of March is when this is valid for. We're going to see that ridge building again in the west, some warmth, well above normal temperatures in the southwest, with that warmth really, expanding through most of the country, really, as you can see. But the Pacific Northwest is, anywhere from 30 to 60% chance of above normal temperatures for that week. Maybe some good news is that it does look to be slightly wetter than normal, or at least a chance of it. At least for the northern tier, Washington, northern Oregon, western Montana, and then near normal in southern Idaho and Oregon. All right, looking at the next slide, should have 1 month. Yeah, so this is the 1 month outlook from CPC. Came out, let's see, the 19th of February. So this is valid for March. And this will be the last update for the month of March. And it is showing maybe some positive news, below normal temperatures in Washington, above normal precipitation, which we always like to see that combo in the winter at least. It's not a strong signal, especially for the temperatures. You can see it's really the kind of the lowest, and we're just like 30 to 40% of chances of below normal temperatures, and that's really just that corner of Washington as well. And then you can see that Idaho is still sort of leaning warmer, at least the southern part. But we'll kind of at least maybe get some above normal precip in March, which we can still accumulate snowpack at that point. As Larry again kind of mentioned, it's not like it's going to save us even if it does pan out. But as far as snowpack is concerned, but certainly not a bad signal. So the 3-month outlook should be on the next slide. Yeah, so again, this maybe isn't such rosy news. We're looking at chances of below normal precipitation there on the right. Not a hugely strong signal again, but it is there on the below normal side, and then above normal temperatures. So this is for April, May, and June. Again, this was issued the 19th of February. These are issued once a month for many time periods out into the future. This is kind of the closest 3-month outlook that we have right now. So not a hugely positive signal for drought, but again, there's always chances that that'll shift in the next month or so. Next slide. All right, looking at stream flow forecast. This is again from the Northwest RFC. These are a selection of water supply forecast points across the greater Pacific Northwest. And as you can see, the forecasts aren't terrible. They lots of greens and blues in there, which are 90% of stream flow and above for 120 day anyway. You can see kind of on the Oregon-Washington border along there through the eastern parts of those states, some of those supply numbers are a little bit lower, down in the 50% range for a lot of them. But really, considering where we're at for precip at the beginning of the year and snowpack, these forecasts aren't as bad as they could be for sure. Next slide. All right, just a quick look at the seasonal drought outlook. So you can see there, at least the southern part of Idaho, we're looking at probably a persistence of drought at this point down there. It is showing at least some improvement of the drought in the panhandle of Idaho, and then along kind of southeast Washington, northeast Oregon there. So maybe some hope there for some improvement, but probably going to persist in Idaho. And then western Montana and the rest of the Washington and Oregon are drought free for now, and so we'll kind of see how that plays out. This outlook is valid again the 19th of February through the end of May. Next slide. Okay, I just wanted to bring up real quick that there has been a sort of shift or transition to how the Climate Prediction Center designates ENSO events. So they are transitioning from using the ONI, which is the Oceanic Niño Index, to using the Relative Oceanic Niño Index, or RONI. And really, they're kind of messaging it as a clearer, more reliable way to track El Niño and La Niña. So I have some key points here that I took from one of their flyers that they have out that's open to the public. And this is just a very cursory summary. And if you're interested in a lot of the more details and how this is going to affect ENSO events and things like that, I would encourage you to go to the website that I put there at the bottom. It's pretty easy, just weather.gov/climate-services/print. And there is a 2-page PDF with a lot more information on how this is going to affect. So they're sort of reclassifying some past El Nino and La Nina events, and it also affects how we're classifying them in the future. And really, it's supposed to provide a more stable and physically meaningful measure of El Nino and La Nina, especially in real time. So it's certainly a net positive, but it is sort of changing how those events get designated, and just something to be aware of. So next slide. All right, so with that, looking at the ENSO forecast, we are currently still in a weak La Nina, but it's looking pretty likely that that's going to come to an end here in the next probably month or two. You can see the second set of bars, the February, March, April forecast, shows a 60% chance of returning to neutral conditions and only a 40% chance of staying in La Nina. So wouldn't surprise me, and by the time this webinar happens again in a couple months, that we've transitioned, but we'll kind of see how that plays out. And then it's looking like you can see through the middle of the year there, it's looking pretty likely that we're going to return to neutral conditions through the summer. And then it is sort of looking like a transition to El Nino is somewhat likely. We're looking at it like a 60% chance by the end of that last bar graph there, September, October, November timeframe, of going to El Nino. So that's kind of the outlook for that. Again, we'll kind of see how that plays. But it does look like the La Nina we're currently in is going to come to an end. All right, next slide. All right, so just to recap briefly, March 2026 is leaning a little bit wetter and slightly cooler than normal in the Pacific Northwest. The April to June outlook is calling for slightly warmer and drier conditions than normal. Streamflow forecasts across the region range from well above normal to slightly below normal. Drought conditions may improve, but will likely linger into spring, especially lingering in that southern Idaho area. And La Nina conditions are likely to persist through the spring before we transition to a neutral this summer. So that's all I had. Thank you.
Thank you so much, Aaron. And thank you for those of you putting your questions in the chat. We'll get to those after this last presentation from Matt Warburton on the 2026 snow drought. Take it away, Matt. Oh, Matt, we can't hear you. I know your audio worked earlier. Maybe. Why don't I go ahead and ask a question? This one I think is for you, Larry, or Aaron. Individual low snow years do not necessarily result in intense wildfire seasons, but compounding seasons probably have more of an impact. Can we be more likely to experience more wildfires after this prolonged and intensifying drought?
Yeah, that's a great question. And right now it's too early in the season to make any definitive statement. And part of it is because there are many things that influence wildfire risk, and conditions during the spring and summer play a big role. So if we have a dry and warm spring, or in the summer, if we have like a showery period where we get some thunderstorms and stuff like that, those can make really big impacts on the wildfire risks that are kind of not associated with the snowpack. With that said, there's this condition of snowpack is just one factor for determining wildfire risk at the elevation.
Great, thank you. And I think we've got Matt online now.
Yeah.
Very quickly, Aaron, we'll come back to you if that's okay. We'll let Matt go forward. So Matt, take it away.
Yeah, can you hear me now?
Yes, we can.
Great. So just in case you needed one more person to deliver bad news to you all today, I am happy to be here, and we'll dive right in. A lot of content to cover. Next slide, please. So today, my primary topic is just going to be going through the snow drought so far this season of 2026 and impacts, and to try to frame this into a multi-year perspective by using one basin in particular as an example. Next slide, please. First off, showing snow monitoring sites, both snow tells and snow courses across the Pacific Northwest. These are showing record low, or the second lowest SWE on record, or snow water equivalent. That's just the amount of water being stored in snowpack. The map on the left is showing records at sites that have at least 20 years of record, and on the right, at sites with at least 50 years of record. So we can see that this year in particular, 2015 was sort of one of the benchmarker low years, and there's several sites that have records dating beyond or going back further than 2015 that are setting record lows this year. And if we look back even more, especially in Oregon and parts of southern Idaho, in that little portion of Montana, we can see some stations setting period of record lows, and in some cases at sites that have up to a 90 or even a century's worth of records. So this year has definitely been notable so far in terms of low snowpack. Next slide, please. And as mentioned by the previous presenters, the primary driver this season for the exceptionally low snowpack across much of the Pacific Northwest has just been the abnormally warm temperatures that we've seen, really through starting in November and going through February. On the right is showing just a temperature anomaly map of the Western US for the periods November, December, and January. The darker the red, the greater the anomaly. We can see throughout this period, much of Pacific Northwest and in general, the West have seen just really warm temperatures so far this season. And that has really driven snow drought conditions across the West, and in particular for our talk today in the Pacific Northwest. Now, another driver, a little less important than what temperature has been water year-to-date precipitation, more notably for Oregon. There are several SNOTEL stations displayed on the left with water year-to-date precipitation that is slightly to moderately below normal. Those are those yellows and orange dots. Now that contrasts with Idaho and Washington, where water year-to-date precipitation has been closer to normal to even above normal. So below normal water year-to-date precipitation, this is showing, I should say not to date, water year precipitation up until February 17th. Those deficits have also been driving snow drought conditions in those areas as well. So water year as a whole, you know, these are two primary drivers of snow drought, and we'll break it down by month now, looking at December 1st. Next slide, please. And the primary driver of snow drought there. On the left is showing monthly precipitation, blue dots well above normal precipitation, green closer to normal. We can see that precipitation overall for the Pacific Northwest during the month of December was above normal. Temperatures still warmer than normal. And that's really resulted in a lot of that precipitation that did fall in the mountains to fall as rain as opposed to snow. Now, we did get some snow accumulation, in particular towards mid-December, but then we had a very warm storm cycle come through, and that resulted in rain on snow, even up at the higher elevations, in the highest elevation SNOTEL stations in the Cascades, across the Blue Mountains, and into the Northern Rockies in Idaho and Montana. And that really hampered more meaningful snowpack buildup during these storm cycles. I chose one SNOTEL station in Washington, Cayuse Pass near Mount Rainier, just to the east, to show this rain on snow signal. The black is the current year winter's trend line, and I have circled that rain on snow event where we see a sharp decrease in snow water equivalent, followed by a subsequent increase with some additional snow accumulation. But it's that decrease that's really hampered that early season snowpack buildup. And we see this signal at several stations, notably higher elevation stations in the mountains across the Cascades, again, into the Northern Rockies, and also including the Olympic Mountains and the Blue Mountains as well. So this was a pretty detrimental event in terms of more robust SWE buildup in December. And now, since it was above normal precipitation, but temperatures were fairly warm, we would categorize this as a wet snow drought. Next slide, please. And this contrasts a bit with January, where precipitation conditions were well below normal across the Pacific Northwest in most cases. Temperatures were still across the board generally warmer than normal, except for parts of Western Oregon more notably. But snow water equivalent, again, still well below normal. And this was what we would call a dry snow drought, where precipitation was just well below normal, and it was a fairly dry period. Showing in the middle there, that middle plot is showing a statewide SWE for Idaho. And during the month of January, we just see this flat line in SWE. This is a pretty similar signal if we looked at the statewide plot for Oregon. and pretty similar to the statewide plot in Washington. Washington differs a little bit. I picked out a site, Beaver Pass in the North Cascades, and in particular for this region, that we actually saw some melting of snowpack that was pretty noticeable on these SWE profiles. Beaver Pass is more of a lower elevation snowtel station, so it's not one of the highest elevations in the North Cascades, but it did experience a rain on snow event towards mid-January, again being detrimental to more healthy SWE buildup during those storm cycles that lasted into January in this particular region. And then there was also some subsequent melting as we approached the end of January and into early February. And Larry mentioned some of the temperature inversions that we've seen across the mountains in January due to these warmer temperatures. And that also promoted some melting of the snowpack as well. So January and that rain on snow event during December were pretty detrimental to snow accumulation throughout the region. Next slide, please. And this is showing a general SWE map, looking at some smaller basins, not quite the larger basins, to break up the regions a little bit better. And here I really want to look at SWE across elevations. And I have two basins picked out. The first one is the Lower Columbia and Sandy Basin. Part of that incorporates portions of Mount Hood. We can see, so the long axis or the y-axis here is elevation, x-axis is SWE. The gray shaded is sort of the normal SWE, what we would expect during a normal year, and the blue shade is this year. And this is derived from model products on the right, whereas on the left, these basins are averages of the snowtel stations that are associated with these particular basins that are outlined in sort of this gray. And what we can see in the basin that's shown on the top graph is that the largest deficit that we're seeing is within the elevation band where we typically see the greatest snow accumulation or has the greatest surface area of snow accumulation in that basin. And that's very detrimental to water supply, where we see the greatest deficit being sort of the elevation band where we source most of the water. But there's still also deficits at these higher elevations. So looking around 7,500 feet and 8,000 feet, even at these higher elevations where we expect, storms to be a bit colder, we're still seeing snow deficits. And that speaks to those storms in December just being exceptionally warm, where we saw rain at these elevations. Now, the second basin we can look at is this Middle Fork, Boise, north of Middle Fork, Boise. Now, this is showing generally healthier, higher elevation snowpack. And this highlights some of the basins that are lighter blue, blue, and green, where those are averages of higher elevation snowpack or SWE. And some of those basins don't really include lower elevation snowtel stations. But from this modeled SWE product, we can see that there are pretty significant deficits when we get below that 8,000, 7,500 feet in elevation, some pretty noticeable pervasive snowpack deficits really across the Northern Rockies, despite some of these bluer and lighter shaded basins. Next slide, please. And so what impacts has this had on water supply? Stealing the Northwest River Forecasting Center's map here. But generally, these reds are very poor water supply outlooks. Your lighter blues and greens are a bit better water supply outlooks, and this is for a seasonal April through September outlook. And so far this season, the lack of snowpack across much of the Pacific Northwest has had severely negative consequences for the water supply outlook late spring into summer. And we can expect this generally poor outlook to likely continue since we're likely not going to see a normal snowpack this year based on historical projections and current future weather predictions. The plot on the right is just showing the normal, if we look at the bar on the right, the normal SWE accumulation by month. So that gold yellow color is December, that green is January, and then purple February, and then the lighter purple is March. You can see most of the SWE accumulation, this is showing Oregon, occurs in December and January. So we missed that period where we see the greatest snow accumulation. And now we're in a period where we see a little bit lesser accumulation, just kind of highlighting the likelihood that we are to see a normal peak snow accumulation coming off of record lows. Not to say it can't happen. If we look in 2025, which is the bar on the furthest left of the plot, certainly had some healthy snow accumulation at this time last year, later in the winter, but we're just unlikely to see that this year. Now, when we think about water availability during the summer and drought conditions into the summer, it's important not only to think about water year precipitation or current water year precipitation and snowpack, but we need additional context to really understand a region's or a basin's susceptibility to drought and low water supply. Next slide, please. Context is important. Assessing drought and water availability isn't about a single metric or even two metrics. It requires a holistic view of multiple parameters and temporal contexts to capture the full picture. We have all these words on the right that kind of play into how we think about summer water supply, summer potential drought conditions. But the one I really want to focus on right now, if you would press next just once, is multi-year precipitation. You go ahead and press it. And for this, I'm going to use the Upper Yakima as a really prime example of a basin that has experienced a multi-year precipitation deficit that's persisting up and through this winter. And the deficit for this particular basin started in about November 2022. And if we look at reservoir storage from the period 2022 to 2025, we can start to see the impacts of this multi-year precipitation deficit. And that includes some years overall snowpack deficit as well. So the maps on the right are showing end of May reservoir storage, or percent of capacity, starting in 2022 after a year of above normal SWE and near normal precipitation. The winter of 2022 was a bit different. This was a year marked by below normal SWE and near normal precipitation, but some carryover. So reservoir storage was near normal. But as this precipitation deficit grew over the next 3 years, we can see the impact to reservoir storage capacity over those same years. Going from 2022 to 2025, where end of May storage as percent of capacity hangs between 53 to 67% with these reservoirs in the Upper Yakima. So, this is just a really prime example of having a multi-year perspective when we think about water supply and downstream impacts to water users and what that means for preparation within any given year. Next slide, please. So a spatial, temporal, and historical context are essential for understanding available water resources and assessing drought conditions, along with their ecological, economic, and societal implications. So not having, horse blinders on when we're only looking at current water year conditions to base our summer outlook for water supply and drought, but really broadening our historical view and what's happened in the recent past. Next slide, please. And just some key takeaways, brushing through these really quickly. This winter snow drought is historic, driven largely by abnormally warm temperatures from November to this point. There's been significant negative implications for water supply and general moisture availability during late spring and summer if snowpack deficits persist at this magnitude. And having a multi-year perspective is essential for understanding a basin's susceptibility to new or worsening drought conditions. And normal doesn't always mean recovered. A normal snowpack year does not mean normal reservoir storage capacity. And an Upper Yakima basin was a great example of that, where that's a basin that's going to take a lot more than normal to get back to that normal reservoir storage capacity in terms of snowpack and precipitation. So with that, thanks for listening.
Thank you so much, Matt. We have some great questions that we'll move to quickly here before we run out of time. First, Erin, did you want to add something to the question about wildfire this year?
No, thanks. I think you covered it pretty well.
Okay,
We can
great. But the first question I think is for you, Erin, and that is why was there no 120-day forecast for the Willamette Valley on your one graph? I don't know if you.
I don't actually know exactly, but I know that there are only certain locations that they do make those forecasts for.
Okay, great. And then I think another one probably for you, Erin, does the 3-month streamflow outlook with many blue and green sites represent an early melt-off?
That's actually a good question. I don't know. There might be. Is Amy from Northwest RFC on? Can somebody else talk? Britt?
No, I
I might
don't.
have to. I might have to. If somebody who asked that question wants to email me, I can definitely get you an answer from
Great,
the
and
RFC.
perfect. And I will link the two of you up, Erin, so no worries.
Perfect.
Perfect. Okay. Let's see. The next question, how are adequate streamflow forecasts squared with the worst snowpack on record? Can soil moisture or total precipitation since October 1 explain why streamflow forecast looks reasonable given the snowpack conditions? It goes on, how are snowtel sites at elevations above 8,000 feet potentially, or are those sites skewing streamflow forecasts? And how do streamflow forecast and manual surveys capture mid-elevation snowpack? There's a lot there. I can break that down if you need.
Yeah, that might be good.
So can soil moisture and total precip since October 1 explain why streamflow forecasts look reasonably good given the snowpack conditions?
That could definitely be playing into it. If with the warmth and lack of frozen ground, a lot of that has maybe infiltrated and brought the base flow up. So it's certainly those can play into it for sure.
Great. And then another part was, how are snowtel sites at elevations above 8,000 feet potentially skewing streamflow forecasts?
This might be a good question for NRCS too, but certainly because the snowtail stations are sort of biased toward high elevation, that's possible. But again, I think I'd have to double check that with the RFC to see what plays into those forecasts exactly. And it might be good to send me an email again, and I can definitely get you a more detailed answer.
Perfect. And then perhaps, Matt, if you want to add to that, or another question is, how do the streamflow forecast and manual snow surveys capture mid-elevation snowpack conditions?
Yeah, that's a good question. Certainly, a lot of our snowtail stations are up in the higher elevations, but we do have basins where we do capture that mid to lower elevation snowpack, whether with a snowtail site or snow course. And as that relates to water supply forecasts, of course, we rely on statistical relationships between these station data and stream flow, but there's also a component where we do make adjustments if we do see especially earlier in the season, a bias more towards precipitation. Some models are going to rely more on precipitation earlier in the season due to just being super early in the snow season. So sometimes there's adjustments after a model run has been done. This year we focused and more, especially for the February 1 forecast that NRCS releases, more on snowpack as opposed to water year precipitation to try to capture the generally poor moisture conditions that we were seeing across the state, which led to lower water supply forecasts. So yeah, it's fairly complex, and of course, our sites don't capture all elevations in every basin, and that's supplemented by some of these modeled and spatially remotely derived products as well.
Great. Thank you so much, Matt. We have a couple questions we didn't get to, but I will definitely connect presenters with those asking the questions. So thank you everyone for your time and attention to our webinar today. And just mark your calendars. Our next webinar will be on April 26th, and pay attention to your email for registration information as that webinar approaches. So thank you everyone for your time today. Thank you again to our speakers, and we'll see you in April.